On a clear night, far from city lights, the sky looks endless. Stars scatter across the darkness like grains of salt spilled on black velvet. The Milky Way stretches overhead, a glowing river of light, and for a moment it feels like everything is visible, like nothing is hidden. Yet this feeling is an illusion, a comforting lie whispered by the cosmos itself. What you are seeing, every star, every galaxy, every glowing nebula, is only 5% of what exists. 5%. That means 95% of the universe is invisible to us, not because our telescopes are weak, not because our technology is primitive, but because its vast majority does not emit light at all. It does not glow, reflect, or shine. It cannot be photographed. It cannot be seen. It can only be felt, inferred, and guessed at through its influence. For centuries, humanity believed the universe was made of what we could see, first with the naked eye, then with glass lenses, then with space telescopes that floated above Earth's atmosphere, capturing images of breathtaking clarity. We mapped planets, charted stars, measured galaxies, and thought we were closing in on the full picture. Each advancement made the universe feel more familiar, more understandable. But the deeper we looked, the stranger reality became. In the early 20th century, astronomers noticed something unsettling. Galaxies were moving in ways that made no sense. Stars were orbiting faster than gravity alone should allow. Entire clusters of galaxies were holding together when, according to visible matter, they should have flown apart long ago. Something unseen was pulling on them. Something massive. Something dark. And that was only the beginning. As instruments grew more precise, another mystery emerged, even more disturbing. The universe was not just expanding, as scientists expected after the Big Bang. It was accelerating. Galaxies were racing away from each other faster and faster, as if an invisible force were pushing space itself apart. This force had no face, no form, no particles we could detect. We named it dark energy. Together, dark matter and dark energy dominate the cosmos. Dark energy makes up roughly 68% of everything. Dark matter accounts for another 27%. All the stars, planets, gas, dust, black holes, and life itself combined amount to a mere 5%. Everything we have ever known, loved, feared, or dreamed exists in that sliver of light. The universe, it turns out, is mostly made of darkness. The problem began quietly, almost politely. In the 1930s, Swiss astronomer Fritz Zwicky studied a cluster of galaxies called the Coma Cluster. He calculated how much mass was needed to keep those galaxies bound together by gravity. Then, he compared that number to how much mass he could actually see. They didn't match. Not even close. There was far too little visible matter to explain why the cluster wasn't tearing itself apart. Zwicky proposed that vast amounts of unseen matter must exist, exerting gravitational pull without emitting light. He called it Dunkel Materie, dark matter. At the time, his idea was largely ignored. It sounded too strange, too speculative. Astronomy moved on, but the universe did not. Decades later, in the 1970s, astronomer Vera Rubin observed something even more troubling. She studied how stars move within spiral galaxies, including our own Milky Way. According to Newtonian physics, stars farther from the galactic center should orbit more slowly. Less mass means weaker gravity. They didn't. Stars at the outer edges of galaxies were moving just as fast as those near the center. If galaxies were made only of visible matter, they should have flown apart long ago. They were being held together by something invisible, something massive, something everywhere. Dark matter was no longer optional. It was necessary. Today, we believe dark matter forms vast halos around galaxies, invisible scaffolding upon which galaxies are built. Without it, stars would never have gathered, galaxies would never have formed, and the universe as we know it might not exist at all. Yet dark matter refuses to reveal itself directly. It does not interact with light. It does not absorb it, reflect it, or emit it. It passes through normal matter almost as if it isn't there. Trillions of dark matter particles could be streaming through your body right now, and you would never feel a thing. Scientists have built detectors deep underground, shielded from cosmic radiation, waiting for the faintest whisper of dark matter interacting with normal particles. So far, nothing conclusive has appeared. We see dark matter only by its shadow, by the way it bends light through gravitational lensing, by the way it shapes galaxies in clusters like an unseen hand molding clay. We know it is there. We just don't know what it is. If dark matter is mysterious, dark energy is terrifying. Dark energy does not pull things together. It pushes them apart. In 1998, two independent teams of astronomers set out to measure how fast the universe's expansion was slowing down. Gravity, they believed, should be gradually pulling everything back, slowing the expansion after the Big Bang. Instead, they discovered the opposite. The expansion of the universe was accelerating. Something was overpowering gravity on the largest scales imaginable. Something was stretching space itself, driving galaxies away from each other faster with every passing moment. This discovery shocked the scientific world. Dark energy appeared to be a property of space itself. The more space there is, the more dark energy exists. As the universe expands, dark energy grows stronger, pushing expansion even faster in a runaway effect. It is a dominant component of the cosmos, making up more than 2/3 of everything that exists. And we have no idea what it is. Is it a constant, like Einstein's cosmological constant, a fixed energy embedded in the fabric of space? Is it a dynamic field that changes over time? Could it weaken, strengthen, or even reverse? The answers matter, because dark energy controls the fate of the universe. If it remains constant, the universe will expand forever, galaxies drifting farther apart until the night sky grows empty and cold. If it strengthens, space itself could tear apart in a catastrophic Big Rip, where galaxies, stars, planets, and even atoms are pulled apart. If it fades, gravity could regain control, halting expansion and collapsing everything in a fiery Big Crunch. Our future depends on a force we cannot see, a force we barely understand, a force that dominates reality itself. It is difficult to comprehend how small our visible universe truly is. Every atom in your body, every breath you take, every mountain, ocean, and star belongs to the same thin slice of cosmic existence. All chemistry, biology, geology, and life itself arise from ordinary matter, the stuff that shines, the 5%. This visible matter formed in the aftermath of the Big Bang, when the universe cooled enough for particles to combine into atoms. Hydrogen and helium emerged first, later forging heavier elements in the hearts of stars. Supernova explosions scattered those elements across space, seeding planets and, eventually, life. We are literally made of star dust. Yet even stars are mere decorations on a stage dominated by darkness. Galaxies form where dark matter clumps, pulling gas and dust into rotating disks. Dark matter shapes cosmic filaments, vast structures stretching across billions of light years, connecting clusters like a web. Between them lie immense voids, regions nearly empty of visible matter, yet still influenced by unseen forces. When we look at images from powerful telescopes, we see glowing galaxies floating in blackness. What we don't see is the vast architecture holding them in place. The universe is not empty. It is full of things we cannot see. This realization forces us to confront a humbling truth. Human perception, no matter how advanced our instruments become, is limited. Reality is not obligated to reveal itself to our senses. The universe operates on rules that do not care whether we understand them. And yet we persist. We build better telescopes. We launch observatories into space. We smash particles together at near light speeds. We analyze faint distortions in the cosmic microwave background, the afterglow of the Big Bang itself, searching for clues. Every answer leads to deeper questions, and every discovery reminds us how small we truly are. The quest to understand the invisible universe has turned scientists into cosmic detectives. Instead of photographs, they rely on indirect evidence. Instead of light, they track gravity. Instead of images, they analyze patterns. One of the most powerful tools is gravitational lensing. Massive objects bend space-time, causing light from distant galaxies to curve around them. By studying these distortions, scientists can map the distribution of dark matter, revealing massive structures that would otherwise remain hidden. Another clue comes from the cosmic microwave background, ancient radiation released when the universe was just 380,000 years old. Tiny fluctuations in this radiation encode information about the early universe's composition, including proportions of dark matter and dark energy. Computer simulations recreate the evolution of the universe from the Big Bang to today, adjusting the amounts of dark matter and dark energy until a virtual universe matches what we observe. Without these invisible components, the simulations fail completely. On Earth, particle physicists search for dark matter in underground laboratories, shielded by rock from cosmic interference. They wait for rare interactions, hoping a dark matter particle will finally announce itself. So far, the universe remains silent, but history teaches us patience. Electricity was once invisible and mysterious. Atoms were once theoretical. Black holes were once dismissed as mathematical oddities. Each time, persistence transformed ignorance into understanding. Dark matter and dark energy may one day follow the same path, or they may force us to rewrite physics itself. We live at a remarkable moment in cosmic history. For the first time, a species born on a small planet orbiting an ordinary star has realized that most reality lies beyond its senses. We have discovered that the universe is not just bigger than we imagined, but fundamentally stranger. Only 5% of it is visible. The rest shapes our destiny from the shadows. This knowledge does not diminish us. It elevates us. To recognize how little we know is the first step toward wisdom. To stare into the darkness and ask questions is the essence of science, curiosity, and humanity itself. One day, we may uncover the true nature of dark matter. We may learn what dark energy is and why it exists. We may discover that the universe is even more complex than we can currently imagine. Until then, every night sky serves as a reminder. What we see is beautiful. What we cannot see is everything else. And somewhere in that vast, invisible majority lies the ultimate story of the universe, waiting to be told. Thanks for watching. If you enjoyed exploring the wonders of our universe, don't forget to subscribe to the channel and share it with your friends who love the stars too. Tap the bell icon so you never miss a journey through the cosmos. Keep looking up and stay curious.